Storage management. Storage management of real memory. Storage management is one of the OS functions, which makes the most effective use of the storage area, and in addition, removes restrictions on the capacity of main memory. In order to implement this function, the technique of increasing the efficiency of computers by using the auxiliary storage, such as hard disks, effectively was developed and introduced. 1. Relocation of programs. The OS searches for enough free space when loading a program into main memory, real memory. In addition, memory blocks that are no longer needed are used again for the loading of new programs. As this loading operation is repeated many times, the number of small free memory blocks gradually increase. For this reason, it is necessary to rearrange programs in sequence from the top of memory and to collect many free memory blocks for reuse as larger free space. This is called program relocation. 2. Roll in roll out. When all the memory blocks are fully occupied and an additional program cannot be loaded, programs that are not needed in a short time later are temporarily saved into auxiliary storage. Whenever they are needed again, they can be restored back into main memory. These save and restore operations are called rollout and roll-in respectively. Roll-in is also called swap-in. Rollout is also called swap-out. In together they are called swapping. This is used in the time-sharing system that will be discussed later. From the standpoint of computer operations, there is the desire to load as many programs as possible into the limited capacity of main memory in order to raise the multiplicity of multiprogramming. The goal is to raise the multiplicity and to efficiently operate each device. In order to do this, it is necessary to reduce the number of programs that use main memory. On the one hand, there is the desire to create programs without considering the size of memory on the development side. In other words, developers want to create programs without being concerned about the limitations of the capacity of main memory. In order to use the limited main memory space effectively, the dynamic relocation of programs and roll-in and roll-out were invented. However, this did not meet the demand for the creation of programs that exceed the actual capacity of main memory. Because of this, the idea of overlay, in which roll-in and roll-out were executed on a segment basis, was developed. 3. Overlay system. As you can see in processes B and C in the illustration, these processes with a high level of independence are created as programs, segments. When they are to be executed, either B or C is loaded into main memory and the other is rolled out. This is the overlay system. It is called the overlay system because B uses a certain area in main memory, and when B is not using that area, C uses the same area, and vice versa. When the program is created, this overlay structure has to be determined. Each segment also has to be made to fit within the limited main memory space. Because of these things, it does not quite meet the demand to create a program without having to worry about the size of memory. Therefore, the new techniques, such as segmentation based on the advanced type of overlay and virtual storage with paging, were also developed.